Hi, this is Joe, and thanks for coming back for another video. This is the second part of the valve adjustment video. In this video, we're going to be doing some inspecting and measuring of the cams, the cam surfaces, the lobes, the followers, and the bearing surfaces. We're going to make sure everything is okay and within specification. So let's get going. One of the most important things you can do while you have the camshafts out and the caps for the camshafts is to perform a very thorough inspection of the cams, the cam lobes, the cam bearing surfaces, and the cam gears. What I've done is I've taken the cams and the bearing caps and I've cleaned them up with a product called LPS, which is a rust preservative penetrating oil, and this will keep the cams from getting any surface rust. It also cleans them up so I can inspect them very thoroughly. What we're going to do is we're going to come in and I've mounted the cams onto the caps because there are bearing surfaces here for the cams to turn on. Normally you would do this on a machinist surface plate, but I don't have one, so we're going to do the best we can with what we have. If you don't feel comfortable about doing this step, or you don't have some of the equipment that I have in this video, feel free to take your cams, bearing surfaces, cam caps to a machinist and have a machinist check them out for you. It isn't that expensive for him to perform these inspections or measurements. What we're going to do is we mounted the cams in the appropriate slots on the bearing surfaces of the cam caps. We're going to rotate the cams and we're going to check very carefully the gears, and we're going to make sure there's no damage over heat marks or any type of scoring or worn teeth on the gear. So we're going to very gently return these and look at all of the teeth, and we're going to make sure that everything looks good with the cam gears. Also, as you notice, I'm turning this. I'm checking for any type of drag or friction as I rotate this cam. We'll perform a run out on the cams here in a bit. Also, what I'm looking for the bearing surfaces on the cam to make sure there's no scoring, there's no pitting, there's no excessive heat marks or damage to either the cam bearing surface or the cap bearing surface. So as I turn these, I'm inspecting each of the bearing surfaces to make sure there's no damage at all. Again, and I'm also making sure that as I rotate the cams are turning very smoothly. One thing I'm also checking are the lobes and the surfaces on the cam lobes. Again, you don't want any scoring, marking, excessive heat marks, pitting, or anything on the cam lobes. So as I rotate the cams, I'm looking at each cam lobe, even running my finger to check to make sure that they're very smooth, they're not damaged, etc. And I'm going to do this with each cam. So as we do that on one cam, this is the exhaust cam. Now we're going to check the other cam, the intake cam. Again, starting out with the gears, take this around. Then we're going to go to how does the cam rotate? Is it smooth in rotation? We're going to check the bearing surfaces on the other cam. We're also checking the lobes for damage. You want them smooth and shiny at the highest point on the lobes of the cams. And as you can see, they're looking very shiny. Once we've done with that and the cams look good and the cams are rotating properly, now we can take each individual cam and we can measure the diameter of the bearing surfaces. Now normally the best way to do this is with a metric micrometer. Now, I don't have a metric micrometer. You could, if you have a regular decimal micrometer, you can convert the reading and you can then measure that with a decimal micrometer. I have a digital caliper that has metric and decimal, and I'm going to try to do that with the calipers. There's a way to do it. You have to be very careful. You have to jiggle the caliper and try to read what the measurement is. The range of the diameter of the cam bearings for this particular engine is 23.959 millimeters to 23.980 millimeters. So let me pull one of the cams out of the cam caps and I'll show you how I'm going to measure it. Again, this, the way I'm doing it is not the optimal way. You want to use a metric micrometer. If you don't have one, you don't feel comfortable about doing this, again, take everything to a machinist and have a machinist measure it for you. First of all, I'm going to make sure the digital calipers is zeroed out with the jaws closed. I'm going to come in with the surface of the calipers and I'm going to put the calipers around that, and I'm going to jiggle gently till I see what the lowest reading is, and I'm getting 23.96, which is within spec. We're going to go to the next bearing surface, do the same measurement, 23.96. Go to the next surface, 23.96. Okay, I can work my way up the entire camshaft, and I've measured this already, and this cam is within spec. So what we're going to do now, we're going to put it back on the cam caps. We're going to take the other cam. This is the intake cam. We're going to pull it out, and we're going to perform the same measurements on the intake cam. Sometimes you'll not get an accurate reading because, again, we're not totally parallel to the bearing surface. But I've done this before and I can read between the numbers, 23.96. Come up to the next bearing surface. $23.96. $23.9. Let's try this again here. Again, doing it this way is very hard because you're not getting the digital calipers parallel to the bearing surface. 23.96. So measure each bearing surface. In this particular case, I've already measured these, and they are within spec at 23.96. Okay, let's take the cam and put it back in the cam cap. While you have these cams out of the cam caps, you also want to take a look at the bearing surfaces on the cam caps. Run your finger over them. These have also been wiped out with LPS, again, to protect the caps and also to get any oil off so you can inspect the bearing surface. Again, you want no scoring, no pitting, no heat damage. They're smooth and shiny. Okay, so that one looks okay. Take out the exhaust cam. Again, we want to inject. Let's move the camera back a little here. We want to check these bearing surfaces as well. No pitting, no scoring, no heat indications of overheating. The bearing surfaces are nice and shiny and smooth. They're okay. Now, one thing you want to do is on some of the locations of the bearing caps, you'll see a little pin. There's one here, and there's one here, there's one here, and there's one here. Do not lose those when you reassemble the cams and the cam caps. You want to make sure that these little pins are in the appropriate place, because that's what holds the caps in the proper position, so you'll get no twisting. Okay, we're going to take and we're going to put the cams back in and make sure they're okay. Now we've inspected the cams, we've inspected the cam caps. What we now want to perform is a run-out test. The manual says that you should have no more than 0.10 millimeter run-out. Now what is run-out? We're going to take and put a dial indicator on each of the bearing surfaces, and we're going to rotate the cam, and we're going to make sure there's no difference in the measurement on the dial indicator of more than 0.10 millimeters. Now I don't have a dial indicator in millimeters. I have one though in a decimal, and 0.10 millimeters is just under 4/1000 of an inch. So we're going to be checking for right around 3/1000 of an inch run out. Let me show you how we're going to set this up. I have a dial indicator with the needle resting on the bearing surface. This dial indicator has a minimum amount of measurement of 0.005 of an inch. I have the dial indicator mounted on a dial indicator holder. What I'm going to do now is very gently rotate the cam, and as you see here, again, this is not the ideal way of doing it. You really need a machinist surface plate, but I'm doing this because this is all I have. If you don't feel comfortable, you don't have the equipment, take it to a machinist, let a machinist do it for you. As you see, as I'm rotating this, we're getting practically zero movement. Each line is 0.005 of an inch, so we're looking really good on this cam. So now what I'm going to do is I'm going to move the dial indicator on the next bearing surface, and we're going to check the run out on that as well. We have the dial indicator set up on the next bearing surface. When you first start rotating, it may jiggle, the needle on the dial indicator may jiggle a little bit, but once you get it settled, it should stay pretty much the same, because there will be some play during the initial movement. But as you can see here, once we start turning this and that movement sort of blends in with the bearing surface, notice we're getting no movement. What I'm going to do is, off camera, I'm going to check all the bearing surfaces of both the intake and exhaust cams, and at the end I'll come back and let you know what the results are. Another measurement we want to take is the cam lobe distance between the bottom of the cam lobe to the tip of the cam lobe. Again, depending on the type of engine that you have, these dimensions for the intake and exhaust cams are going to be slightly different. So you want to make sure you have the proper specs for the engine that you have. The ideal way of doing this is with a metric micrometer. I don't have a metric micrometer, and I don't have an inch micrometer between 1 and 2 inches. So I'm going to use my dial calipers or digital calipers to measure this. And I've done this enough times. It's very tricky, very hard to do, but if you're careful, and you can get a fairly accurate measurement. We have this is an intake cam, and on the intake cam we have a measurement of 36.58 millimeters to 36.63 millimeters. Let's go ahead and just measure a couple of the cam lobes on camera to show you. You have to make sure that the the digital caliper is parallel to the cam lobe, and that is really hard to get set up properly. And you just have to keep on trying until you get within the measurement. And there's 36.58, which is the minimum measurement. Let's go up to the next cam lobe. There's 36.57. I know I'm really, there's 36.58. So there's two of the cam lobes. I'll do the others off camera. But we know that at least on the intake cam, we're looking good right now. Let's get the exhaust cam. Now the exhaust cam on the type of engine that I have has a different measurement. This has 35.78 to 35.83. So by measuring, there's 35.76. So we're a little off. So let's try to take another measurement. Sometimes it helps to jiggle the calipers. 36.57. Or 36.78. There's 35.78 or 35.80. Let's see, there's 35.79. Let's try another lobe. .78. That's the minimum measurement. So again, it's really hard to do this measurement with digital calipers, but if you're careful and take your time, you can do that. I'll measure the rest of the cam lobes off camera. These are the measurements we want to take to make sure our cams are within spec. We're over at the engine now, and we're taking a look at the cylinder head. What we want to do is we also want to come in and inspect the bearing surfaces. Each, make sure they're smooth. There's no pitting, scoring, heat damage. And we're going to look at each bearing surface. We're going to make sure there's no dirt or anything in any of the grooves or anywhere around any of the bearing surfaces. If there's any dirt or grit, we want to clean that. We also want to look at each valve stem top and make sure there's no damage, scoring, pitting, etc. on any of the valves. We want to make sure that everything looks fine. We want to check the valve spring caps, make sure there's no damage on those as well. Now, this engine only has 16,000 miles on it, so it's basically been just broken in. Normally, if the engine is a bit older, has more miles on it, you should come in with plastic gauge. Put plastic gauge on each of the bearing surfaces and measure how much clearance you have between the cam and the bearing surface. Normally you would put plastic gauge on the bearing surfaces, and then you would put the cams in and you would torque the cam caps down onto the bearing surfaces in the head, and then you would disassemble, and then using a little indication you could tell what the bearing clearances are between the cam itself and the bearing surface. What happens is plastic gauge is a little piece of very thin plastic at a set thickness, and when you come in and torque down the cam caps onto the cam on the bearing surfaces, that little plastic gauge will change its width. The more it presses down, the wider that plastic strip will be. They then give you a little index with the thickness, and you can come in and compare the thickness of the plastic gauge against how many thousandths of an inch or how many millimeters clearance you have between the cam and the bearing surface. But again, this engine is pretty new. Unless there's some damage in there, I'm not going to do a plastic gauge check. This engine has basically just been broken in. So everything is looking good. Before we assemble, we're going to clean everything, make sure there's no dirt or grime or oil in there. We don't want any dirt. And I keep the head covered with a paper towel so that no dirt or grit or anything will fall down into the head's area, because we don't want any gunk or grit or grime or dirt to get on that head. Let's go over and take a look at the cam followers now. Okay, normally you would perform this inspection the same time you're checking your shims, and that way you can perform both of these steps at the same time. You want to take each cam follower out of its storage location. You want to take your finger and you want to rub it on the surface. You want to make sure there's no burrs, there's no pits, there's no scoring, there's no heat damage. You want to inspect all the way around the follower, again making sure there's no damage. If you look inside, you notice there's the little indentation in there. That is where the cam shim sits. So when you put your cam shim back in, you will put it in this little indentation area. And you always want to take you notice when we first pulled the shims out, there was a number written on one side of the shim. When you're putting the new shims back in, you want to make sure that those numbers on the shim are facing that little indentation on the cam follower. So what we're going to do off camera, I'm just showing you on one, but off camera I'm going to inspect every single cam follower and make sure everything looks fine. Once that is all done, that will be the actual end of this video. And when we get the new shims in, we'll have another video of how we actually insert the new cam shims and reassemble the head with the cams and the actual cam bearing caps. So hope you enjoyed the video. We'll see you next time.